Namaste, good afternoon to everyone, good evening, and good morning. This is live on YouTube also. Welcome to Rajiv Gandhi Center for Advanced Technology for this fantastic webinar on 5G Advanced and 6. And this 5G Advanced and 6G wireless research will be presented by Keysight. Thank you, Agmatel, the team that organized this webinar in collaboration with Keysight. Thank you, Agmatel, being our partner at RCAT, having Apple with us, and soon to be with Keysight will be partner. Rajiv Gandhi Center of Advanced Technology is a new age IT finishing school established by Government of Rajasthan last year. Within a year, we have reached out to 11 technology partners who are partners with us, offering globally recognized certifications. And we have academic partners, more than 10 now, who are also taking the support of RCAT in developing advanced and emerging technology education and training. So today's webinar is in the context of Mission 2030 Rajasthan, the Rajasthan government's ambitious program and initiative to get suggestions and recommendations from common citizens, experts, public intellectuals, and technologists on how to develop the state in next 7 years so that Rajasthan can become a developed state by 2030. So this webinar is in that context, and we are looking at how 6G technologies can actually be useful for all of us in making the economy stronger. Today, we are thankful to Keysight team to have nominated Prasad Petkarji, who has a strong background in telecom industry with significant experience, close to 20 years, in device testing, base station, network testing, and optimization. He holds US patent, which is a notable achievement and testament to his expertise in the field. As a wireless segment manager at Keysight Technology in India, he is responsible for managing the support to Keysight's wireless products and services provided to the customer and ensuring they meet the needs of customers in the region. He's been associated with several these platforms and solutions. He supports tier 1 operator in India and all the major chipset and base station manufacturing companies. He has completed his master's in data science from BITS Pilani. Thank you, Prasad Petkarji, for joining us for today's webinar. May I thank Vivek Parikji and Team Magmatel for making this webinar possible. And over to Prasad Petkarji to take the discussion forward and share with us how the current 5G advanced and the forthcoming 6G wireless communication are going to transform the technological digital ecosystem in India, and how Rajasthan as a state can leverage its benefits to make Rajasthan a developed state by 2030. Over to Prasad Petkarji.
Thank you, sir. Thank you for this opportunity, and I welcome all the delegates invited by RCAT and the Rajasthan government. So I when this opportunity came, I was very pleased, and I'm very enthusiastic. I have a lot of enthusiasm in terms of explaining how the technology is going to change. Right now, what is the present status and how it is going to be a foundation for 6G, where there needs a lot of development, and it would be an ubiquitous coverage across the globe. So let's do a deep dive in the technological aspects of the paper which I have to present. So just to give you a brief idea about what Keysight has been. So Keysight is a part of HP, which was established in 1939, which then again spinned off into Agilent Technologies, and now since 2014 all the communication products are under Keysight. So what does Keysight actually do? So Keysight is in various markets: commercial communication, wherein we talk about 2G, 3G, 4G, and now we are talking about 5G. Then we have semiconductors. We are into automotive and energy, that is AV, AE. The virtual, electric vehicles, the autonomous vehicles, everything falls under this automotive energy. Then we have the aerospace and defense, uh, where we work with the various defense customers, and followed by the IoT market as such. We provide solutions right from design phase, emulation, prototyping, testing, and then manufacturing, and of course optimization. So we have hardware, software, and the required services to support the complete workflow. When we talk about the commercial communication, right? So, made if we talk about 5G, we support, or we have solutions from devices to support or develop devices, the radio access network, the base stations, then the core, mobile core, right? So we have various solutions which helps to develop the mobile core, followed by the network assurance solutions which are there, which helps to cover all these end-to-end products. We also have various security related solutions, and this covers the complete commercial communication industry across the globe and even in India. So, as you are aware, there has been a lot of transformation in the cellular communication, right? So, initially it started with 1G, when there used to be phones, mobile phones, followed by 2G, where we started seeing a lot of voice calls. There was a lot of mobility. We were talking about coverage. Then we started sending messages. Then we started, the engagement of the data sharing started increasing. We started sending SMS. We started working on making voice calls, which led us to 3G, where the data demand started increasing with 3G, and that's where the need for 4G came into picture, wherein uh, there was a boom in the data consumption in India itself. We saw a lot of traction past 10 years or so. Looking at 4G, there was a lot of drive which brought into 5G, wherein we see a lot of use cases towards. There were a lot of use cases towards smartphones, drones, robots, IoT devices came into picture. We are talking about AR, VR, AI. So I'll just explain what exactly is AI. So the amount of data, the frequency band that we have in 5G is 20. The amount of data that we are talking about is 20 Gbps, which is a huge amount, huge. This is driving 6G, and where we will be having uninterrupted coverage. We will have multi-sense communications, real-time intelligence that will drive the whole industry, and we are talking about throughputs up to 1 Tbps over the air, or that is what has been expected from 6G. Of course, once 6G starts coming up, we will have what will be there in 7G. We that is something which is very exciting, and we'll have to wait and see how that unfolds in future. So, what is the present mega trends in the industry? We have mobile devices as 5G, virtual augmented reality is something which has been looked up. So we that's where Meta or Facebook is focusing into. Then we have new devices across the industry verticals, right? So there is a, a requirement like IoT, which is where we are talking about smart houses, smart meters, smart devices, so on and so forth. Then there is a focus on location based services. So as soon as you move to a market, you will get a lot of information about what all products are there, what is the top selling products are there. So that is again related to location based services, followed by connected cars. This is again an interesting field or interesting use case where 5G is trying to contribute, and we are seeing a lot of traction happening in connected cars. A lot of tier one vehicle manufacturers have started investing in this. We have a lot of prototype globally which are being tested right now for this connected and autonomous car. Of course, should robotics could be one more interesting field where we will see a lot of robots. Maybe they would be used in manufacturing. They can be used in maybe in hospitals to do surgeries, right? So robotics is again an evolving field. All these use cases are driven by would and will be driven by, in fact, AI. Since start of this year, you must have seen a lot of traction that has been happening on AI. A lot of companies are investing in AI, and for driving AI, we will be requiring a lot of cloud applications across the globe. And again, when we are working on cloud, of course, security cannot be kept behind. Security also plays a very important role, uh, a very important role when we are working on the cloud, because then we have to ensure all these elements are working perfectly fine without someone entering into the network and causing harm to the network. So security becomes an important aspect of the uh, whole ecosystem. And with this, if you see the standardization, that so 3GPP is an entity which defines the standard for 5G. So it has been defining standards from 3G, 4G, and now for 5G. And going forward, we will see a lot of standards been defined by 3GPP. So right now we are in 2023, where release 17 there has started is started maturing, and we will soon see by end of the next year the commercialization of release 17. So we'll start seeing devices which supports the features defined in release 17, and then in release 18, so the research has already started for release 18. I'll show you the next slide, which talks about what all features are there in 16, 17, 18, so that you can understand how the technology is moving and at what pace. So when will 6G will be there, right? So 6G will be there at somewhere around 2027, and that's where we would be trying to bring in a lot of solutions towards the use cases of 6G. So what do we have till release 18, right? So in if you see in release 15, the objective was to just give the coverage and data throughput, which is one of the pillars of 6G. What about release 17? So release 17 started talking about URLC, wherein the low latency networks is started forming. We see a lot of private networks coming in. Operators like the major tier one operators in India have started working with private companies to provide private networks. There are a lot of investment that has been done, or there are a lot of solutions been developed for positioning solutions. Then the NR side link, which is an important criteria for connected cars, followed by release 17. So the research has started for release 17. The specs have almost been freezed out for release 17, and we will see a lot of enhancement or the development or the deployment of release 17 across the networks and across the use cases. So we see a lot of development that has been done on URLC, on the network side, on the device side, with respect to using the positioning aspects of it. Uh, there is one more area that has been developed, that is the red cap, which is reduced capability, which is more towards IoT devices, right? So all the electronics devices would be connected to the network. A lot of information would be brought in through red cap. So there is a lot of development that already has started for red cap, and we will soon see a lot of devices supporting red cap. Now coming to the uh, automotive side of the network supporting the automotive sector, right? So there are a lot of new features that have been added to support the connectivity, because end of the day it becomes very important that we have the low latency in the network, we have the communication between vehicle to vehicle, vehicle to network, vehicle to even pedestrians at times. So these lot of features, these enhancements have been done in the communication that happens between the vehicle and the network. Then there are a lot of there is a new domain that has started, right? So we have been working, or we have been using the terrestrial network. That is, the base stations are on the uh, uh, on the ground, and then we have we were so now there is a limitation when there is a ground based network or the terrestrial network. That is, there are a lot of places where there are no coverage. So those areas usually, people who are able to use the satellites, sat phones, right? So those can be, those are being used, but then again it has its own limitation. You need to have a specific phone, then the connect, then it needs to be, you need to have that uh, uh, you need to have that associated with the provider of VSAT. Uh, so eh, so we had to come out of that particular limitation, and that's where this NRNTN has been, the specification has been formed for in release 17, and we will see a lot of devices coming. In fact, there are Apple has already have started integrating, or we do see in iPhone 15, we will see NRNTN available on the phone. So wherein the user can, after taking subscription, can use the phone wherever there are no coverages. The satellite would be providing the required coverage, and there is a specification also defined for the NB-IoT NTN or NR-NTN on the devices, wherein you can send do emergency services, or you can connect uh, important services without any interruption. Right? Even though if there is no coverage, we will continuously have the satellite coverage, and we should be able to provide that. So NB-IoT, NTN, NR-NTN is the focus in release 17, followed by the public safety, and then the XR and VR. Right? So this is virtual reality. We have been seeing a lot of traction wherein Meta has been trying to bring in those goggles, the VR AR goggles, right? So that is something which we will soon have that. But then as we move towards release 18, we there would be a lot of enhancement on these features which I just mentioned. Plus, there is something which has been started to formulate, wherein we will have AI and ML, wherein a lot of things would be controlled, because there is a lot of data that would be coming in from different sources, right from devices, right from base stations, so on and so forth. So that data would be churned by the algorithms in the artificial intelligence, and it will be used for inter air interface, to ensure that the link is always there, to ensure that you get the best quality of service, to ensure that you will get the best quality of experience. So release 18 will also focus something very new, very unique. People have started already using, is that is uncrewed aerial vehicles, where we see those drones, right? So this will be an important area wherein the those drones will be connected to the 5G network. So why I have been discussing this till now? The reason is this is something moves towards 6G. So when is the timeline? So as I mentioned earlier, the 6G research has already started. So it has started since 2020, and it is at peak right now, and it will be there for next 2 to 3 years, wherein people would be contributing a lot of new use cases, new technologies, in terms of reducing URLLC, in terms of using AI ML, in terms of using new bands, so on and so forth. So there is a lot of research going on right now. People have started investing. It is on the 6G network, and there would be a lot of, you will start seeing from now. In fact, people have already started having some beds on the physical layer, and we will see a lot of demonstrations happening going forward for next 3 to 4 years, and somewhere around 2027, 28, we will start seeing the new products supporting 6G. So what is the vision of 6G? So 6G will fully connect the physical, digital, human world, facing the opportunities and challenges of growth and sustainability. It will benefit humanity for decades, and it will provide the connected intelligence across the globe. There would be full coverage across the globe, and there would be a lot of inclusion of very various digital devices in our life. We have in last 15 years or 20 years, we have seen lot of inclusion of digital devices, right from computers, laptops, device phones, and there are a lot of other digital devices at our home that we have been using, right? So we TV itself has changed so much. uh, so we have that. So there is a forward moving path with respect to the digital devices, and we will see that this will be the enablers of 6G. So 6G will be an ubiquitous wireless intelligence, right? So it will provide uninterrupted intelligence to the wireless devices. That's the whole objective. And the the point which I was explaining earlier, right? The release 17, release 18, whatever features that you saw earlier, and we will see, of course, we will see new features in release 19 and release 20, which would be which will be enabling or would be the drivers for the 6G use cases. So what are those use cases, or the models that are there? There would be a lot of holographic and multi-sensory communications that will be happening. It will have the internet of things, but social internet of things. So this is a new concept that has been coined in, which is very much near to your AR and VR. There would be a lot of AI powered H2H, H2M, and M2M networks, right? So mobile to mobile networks, heterogeneous networks, so on and so forth. So there would be a lot of AI ML that would be used in terms of communication, in terms of deploying the use cases of 6G. There would be something called digital twin. I don't know if you have you must have heard about digital twin, and in next few slide I'll explain what is digital twin. It's basically like testing something. So let's say if I develop a mobile and it goes to the actual network, before sending that device to the actual network, I'll test it in lab, creating a digital twin of the real network. So it's like bringing the actual network scenario inside my lab and test the device before deploying it on the network. There would be a lot of advanced industrial transportation and cloud native IoT. So vehicles that would be there, or even the robots that are there in the industrial. So you must have heard about Amazon using robots to move their, or Amazon or Flipkart using robots to move the inventory in their warehouses. So that's where this is coming from. New communication environments like land, sea, and air and space would be seamless, because of the NTN or non-terrestrial communication that will be happening soon. Emergency and disaster management would be very easy. The critical infrastructure that would be there would be a critical infrastructure that would be dedicated for managing emergency and disaster management. Some of the countries already have this. We in India, there is a plan to deploy the emergency and disaster manager. Some of the governments have already started doing it, but on our country level, this there is a roadmap to have this in, or this would be made compulsory for all the operators. So these are some of the performance indicators for 6G. So 6G, we need throughputs of 1 Tbps, latency of 0.1 milliseconds. So this is like, it's like, defying the physics. And that's where we are working on. So whatever physics right now is applicable, maybe 10 years down the line or 5 years down the line may not be applicable, because we are evolving in terms of technology. We are evolving with the material that we are using. So uplane latency would reduce to zero point 0.1 millisecond, which is something right now is achieved on the Ethernet network, and this has to be achieved on the uplane or air interface. The reliability has to be, the nine nines, so it has to be almost like perfect. The connection density will be higher. Location precision would be there because the devices would be always be connected to GPS. The battery life has to be infinite, uh, and energy efficiency, there must be the highest energy efficiency. So whatever products are deployed for supporting 6G, the energy consumption has to reduce. So operators have started working on monitoring the energy consumption that has been done by the base stations or any network element that they deploy on the network. So 6G will go beyond its target of 5G. So the blue line is 5G. The orange line is 6G, and that's where the target is. And it would be conservative to be. So we have to be ambitious to achieve what needs to be achieved in 6G. So what all verticals right now has been talked about in 6G. So first is the new spectrum technology. So we are talking about 400 megahertz up to one terahertz, right? So we are talking of any and every frequency range that is possibly available. We are talking about the channel measurement and model. So the research is happening in all these four different domains right now. So which I was mentioning earlier. So the channel measurements have to be done because not every frequency, so like 400 megahertz, that though 5G was talking about the lower frequencies, but it did support from 300 megahertz, 360 megahertz, but still there are no networks which have been deployed. There has been not much of a channel measurement or channel model that are there available for those lower frequencies. Similarly, beyond 50 gigahertz, though it has been there, the 5G is talking about, including higher frequencies like 70 gigahertz or 80 gigahertz, but still the research in 5G is not happening. But 6G, of course, they are talking about terahertz of frequencies, and people have started working on creating those channel models, doing the channel sounding for different frequencies, and whichever is possible or gives the best performance will be deployed on the network. Then AI ML is something which will be a native to the network. It will be in the DNA of the network. The AI ML various algorithms would be running. A lot of companies have started investing in their AI ML algorithms for telecom networks. There would be a lot of synthetic data that would be trained, that would be created, so that it covers all various aspects of the complex networks that will get deployed. Various use cases would have to be tested with different data, and of course then the validation of that data is happening actually. uh, then we have the digital twin. It will create a high fidelity network using digital twin. As I mentioned, it will create a real model in the lab, which will help to create a better device or a device which is functioning at its 100%, and it will create various models which are applicable for the future performance, and that would be brought inside the lab to test and develop the device. Then new network topologies have been talked about. NTN is something which I mentioned earlier, non-terrestrial network. I have some more information on this, which in the later slide. Then we have this Open RAN solution. So Open RAN or ORAN was already is there in 5G, and people have started working on ORAN. But again, with this new concept in 6G would be more dominant. You will see a lot of things happening supported by AI/ML and digital twin. So ORAN would play a majority. It will take the majority of the chunk of the whole network. And of course, network security is something, because you know we I have been hearing about quantum computing, and quantum computing it has been said that it will crack a lot of codes, algorithms, or even passwords within milliseconds. So then accordingly, the network security has to change. So the so since we are working on supercomputers on that side, then the security also needs to be in line with the changing technology. So, as I was mentioning earlier, right, the new spectrum that has been talked about, we see the orange color bars for these are the frequency chunks that were taken for 1G, the orange color. The pink color or the violet color is for 2G, 3G. The gray color is for 4G. So these are the bands which have been widely used for various technology. While for 5G, we have this blue color line, and 6G is something which would be running across from 400 megahertz up to terahertz. That is the 1 millimeter wave, 1 mm wave would be there. So we are talking about, and a lot of research has been done in this complete frequency space. Sorry, so I'll just go back for a minute, and then but we are working on these bands, right? Then you may ask, what is the bandwidth? So the bandwidth aspect is still an open question for 6G, because we do not know, should we support 1 gigahertz of bandwidth, should we support 5 gigahertz of bandwidth, or should we support 10 gigahertz of bandwidth. So just imagine, when we are talking about 1 gigahertz in 5G with 100 megahertz, we are talking about 4 or 5 gbps of throughput with a single cell, with a single frequency. So just imagine, when we are talking about 5 gigahertz of bandwidth, how much speed should we be talking about, or should we be seeing, right? So it's a good thing. That will actually enable a lot of, there are possibilities when you have higher bandwidths. So yeah, so 6G will improve the existing spectrum use. It will create a smart spectrum sharing. You have a lot of spectral efficiency that would be possible. MIMO, must have heard about massive MIMO, multi-user MIMO, or just MIMO. So what? So with this type of frequency, do we need MIMO? That would be the first question I may ask. Or do you need full duplex, or just a simplex should work for this but bigger chunk of frequency? So there is a lot of possibility that brings in with higher bandwidth. So 6G is going to be spectral efficiency, and efficiency gain will come with that was not available with the earlier technology. So these are some of the candidate frequencies that has been worked on. So 7 gigahertz is something which a lot of universities and companies have started working in. 7 to 16 gigahertz research topics are has been discussed for coexistence, sharing, cell density, and coverage. 16 to 24 gigahertz has been talked for FR2 like scenarios. 24 to 71 is for coverage, energy efficiency, mobility, handovers. 71 to 110, it is more for energy efficiency, noise bandwidth, mobility, and coverage. So it would be like indoor coverages, wherein, or for private networks, we are talking about the 71 to 110. 110 to 170 gigahertz, apart from the coverage, energy efficiency, we will see noise bandwidth and mobility. And beyond 110, 170, uh, uh, again, we will be talking about the link budget and all. So at the bottom, we see that NOMA, waveforms, channel sounding. So on these frequency, people have started doing their research. So for 7 gigahertz, it's almost like it will be used for NOMA, waveform, channel coding, unlicensed Wi-Fi or Wi-Fi, unlicensed band or Wi-Fi, advanced MIMO, satellite, and the LNAs and antennas would be are been tested for greater than 7 gigahertz frequencies. Radars and mobility coverage is not a focus over there, because the other frequency ranges are being used. So these are the research areas, and with different frequencies, universities, companies have started investing or performing those developments. Then now coming to AI in RAN. So you, as you are aware, right, with present systems like 2G, 3G, 4G, and 5G, the networks are complex. We see a lot of call drops or poor performance at times when we are using data networks. So the complexity is too high. There are no analytical models that are available to solve these problems of power. So power in the sense of what the mobile receives or what the power with which the mobile sends. So that's where this RAN optimization problem is an immediate segment where AIML will be providing, has started providing solutions to. So in 5G, people have started providing those algorithms to solve those problems. So even it will permeate in the aspect of RAN, core, and application. So air interface, where physical file layer, where coding and modulation has been worked by AIML. Similarly, the MAC layer, where MIMO weight optimization for beamforming and the channel feedback stand, that is the CSIRS or SRS like channels which are there or signals which are there would be managed by AIML. So, plus the radio resource management like mobility, beam management, dynamic spectrum, that would be again managed by AI. Energy optimization is again something which will be taken care by AIML. Uh, Rick is so we spoke about ORAN. ORAN has one component called RIC, that is RAN Intelligence Controller, which is pure play a ML based optimization module, right? So the ORAN has already standardized or they have created the specification for RIC, that is the RAN Intelligence Controller, and that is has started providing the intelligence in the network where these type of optimizations will happen. And in 6G, this will be taken to a next level where 6G will be an inherent module of the whole of the network as well as device. So AI in RAN is going to be a phenomenal uh, change in the whole technology. So just an example of the air interface, how that will happen. So we have a ML deep TX where encoding, symbol mapping, and modulation will be taken care by the ML TX, that is the machine learning TX. Similarly, on the receiver side, the ML would be working for channel estimation, equalization, symbol mapping, and decoding. Right. So that would be on the ML, so that it is able to reproduce the data that is it has received. And 6G, the physical itself will be a part of the whole design using ML. So this is one example that will be, or people have started working towards 6G. And the digital twin, so the sandbox for evaluation of new model. So you bring a custom model, insert it in digital twin and test it, check the data performance. That this next step would be the data would be fed to AI/ML to generate the synthetic data for training, and then the followed by the optimization engine, which will feed the output of the AI/ML to the or the optimization engine. So this is how the digital twin would be very helpful for the 6G, or people have started creating those use cases for digital twin. NTN, as I was, so this is again an important aspect which people have started working on. So we have the networks on the ground level. Then we are talking about 150-meter, where we have, 150-meter to 10 kilometers, where we have the aeroplanes, or we may have UAVs as well in that sector. And anything beyond 600 kilometers and beyond, that is LEO, GEO, and MEO satellites, would be providing coverage to all the ground level infrastructure that we have. Sea, air, water, space, anything and everything would be covered by 6G. So we will have a global coverage using NTN. So the journey towards 6G begins on a solid ground. Who have started working on it? What all areas, as I mentioned earlier, these are some of the add-on feature test cases that have started. So Keysight provides the OTA capability for testing the FR2 devices. We have solutions which are working on 400 Gbps, 800 Gbps for hyperscale and the edge data centers. We have the Keysight Application and Threat Intelligence Research Center, which provides the cybersecurity issues worldwide. So the 6G action worldwide that has been taken, a lot of the font which is in red are all the government organization, while the font which is in blue is all concessions or universities which are uh, providing research or doing research in 6G with various different applications. So in US, Europe, China, South Korea, Japan, and in recent times, even some of the IITs in India have also started investing in 6G on the physical layer, creating custom or flex waveforms, custom waveforms, flex symbols, and some of the other modulation criterias are being taken care in India. The customers have started working in it. Some of the private customers who are leading in the 6G research are Docomo, Entity Docomo, Samsung. So Entity Docomo is working on sub terahertz, wide band bandwidths, non-orthogonal physical layer, and extreme MIMO and AI5. So these are some of the concepts where Docomo has started working. Samsung has started working on terahertz, advanced duplexing, native AI, computing on the device itself, and so on and so forth. Nokia also has started investing in this domain. Ericsson, LG, Qualcomm, Fujitsu, and Huawei. So all the big names in the industry, telecom industry, have started uh, doing research for 6G. What all challenges are they facing? Then the challenges that they see right now is the sub terahertz research. So the semiconductors, components, transmitter receivers, antennas. These are very difficult to get when we are working on higher terahertz frequencies. Channel models and characterization at terahertz, sub terahertz frequencies again is a challenge, because not all the frequencies has been explored, and that's where we do not have those channel models. Then low latency and the time deterministics is again one more problem. Non-terrestrial network designing is again a challenge because of the above reasons that are there. Of course, computing, semiconductors, optical architectures are required when we are working on the uh, TBPS, like data throughputs, energy efficiency, energy harvesting, battery-less techniques, right? So these are something which has been thought about for the 6G research. Edge intelligence, modeling, and AI is again something which has been worked on. And of course, security, once again, encryption and recovery techniques has been thought about, has been worked on. So, where does Keysight stand? What Keysight does when we talk about the wireless ecosystem? We provide a lot of parametric measurement fundamentals, right from digital RF, signal generation, signal analysis, network analysis, metrology, and time domain measurements have been done under that. Wireless devices like protocol development, component development, conformance, and so on. So Internet of Things, wherein solutions for healthcare, smart homes, wearables. That's where we have solutions for data centers, high speed digital systems. We have uh, various solutions, AWGs, oscilloscopes, so on and so forth, which are required for testing the high speed digital. Then the cloud networks, where the visibility and security and monitoring of the cloud has been taken care of. Then energy solutions, the NFVs, virtualization, network visibility, network test, chip verification, the network security. So has been tested, manufacturing testing, and multi-technology platforms, wherein we test CV2X, DSRC, connected cars, satellites, and so on and so forth. And of course, to cover everything, we do provide a lot of solution wherein there is the design and automation can be done. So this is one of the sub terahertz test bed that we have. We do have one video on YouTube available where you can get an information and the actual test of this. The test setup is we have a AWG, which is a wideband IF. We have a PSG, which acts as an LO. We have an oscilloscope of 30, 33 gigahertz with 4 channel to analyze the signal. And there are some VDI components which acts as a up converters of the frequencies in 110 gigahertz up to 1.7 terahertz of frequencies. So this is the setup which some of the IITs, some of the universities have started investing in. We have started using this tool. We have the VSA and some IQ tools with which you can create your custom waveform. Flex frames can be created with the solutions over here. So with this is my last slide. So our request is let's work together. Let's change the world together. Start your 6G journey with Keysights, and we are there as an experts to guide you in this technology. Thank you. So if you have any questions, please feel free to ask.
Uh, Thank you so much, Prasad sir, for giving a very comprehensive overview of the 6G technologies and how in the technical terms also, in the energy terms also, economic terms also, how they are going to be useful. And as you might be knowing already, India has kind of publicly announced to be a leader in 6G. That also gives hope and creates opportunities for all of us who work in the technology sector, in the education sector, also for development in the socio-economic sector as well. There are several such questions that have come. I will just select a few of them that have come on social media and to our WhatsApp groups as well. So, Prasad sir, one question I'm going to read is this one, which says, um, how can 6G drive economic growth sectors outside telecommunication, such as healthcare? You might club them, such as healthcare, automotive, and entertainment. What new industries sectors might emerge as a direct result of 6 technology, and how can 6G technology enhance productivity and efficiency in business? So these questions, I'm clubbing them under economic benefit. I'm putting them here on the chat. So please, you can have a look at those questions also, and you can have also brief answer to them.
Yeah, thank you. I think this is a very good question because if we are working on a new technology, we need to know what is the economic impact that it will have on on various sectors, of course. So to answer to the question, right? So 6G for sure will drive the economic growth uh, uh, for various sectors. It may be healthcare, it may be automotive, or it could be anything. So how healthcare? The healthcare, we there are a lot of investments going on, or there are a lot of research going on, wherein robots would be connected to 6G, and an operator sitting, and a neurosurgeon sitting in one place can do an operation of maybe an emergency operation of a brain in a village, right? So this will drive the use cases in healthcare. Similarly, in automotive, for sure we will see a lot of positive implications that are there in the automotive segment, because we have seen there are vehicles which have started becoming autonomous, and this will drive the automotive industry. Uh, so I So I hope I have answered this question. So is there any other point in this question?
One more question on the environmental and sustainability concerns. What are the environmental implications of deploying 6G, especially considering the infrastructure and energy requirements? And second question, how can 6G technology be leveraged to support sustainable economic growth?
Yeah, again, this is a fantastic question. So, and because environment again is an important aspect which we have to sustain it, which we have to take care of. So there are a lot of talks going on wherein we are talking about battery-less devices. So what I mean is the what it will drive us towards is that we will have phones without batteries. The second thing is the network elements which are there, which draw power. They so there is a conscious steps that have been taken or will be taken, wherein the that are deployed in 6G will draw less and less power, which will of course support our environment. We will be working towards securing our environment and drawing less from the environment. Thank you. Any other question?
Thank you so much. We are very happy to have your presentation that has given us a kind of brief overview of the 6G technologies and kind of the challenges and opportunities that it will offer to us. So and it will also be impacting the digital transformation journey of the country. As the government of India is committed to be a leader at the global level in 6G. So states like Rajasthan will also be at the forefront, given Rajasthan's track record, a successful track record in technology and IT technology implementations. So with this, we would like to invite Vivek Parikh to offer a vote of thanks today for today's session. Vivek Parikh.
Uh, Thank you so much, KK sir. I would like to thank Arcade, of course, RISL, and Mr. Petkar from Keysight. And it will be it is actually a great pleasure to hear this his views on 6G technology, how it is going to change the socio-economic economic setup in the entire country, and especially in Rajasthan, we are going to get the leverage of it. Uh, thank you so much for all to all the viewers who has taken out time and been this session. Over to you, KK sir.
Thank you, Vivek we are grateful to Vivek for connecting us to Prasad at Keysite. And please accept the heartfelt thanks from on behalf of ARCAT. We are signing off now. It's a fantastic webinar, also available on the YouTube. So for your repeat viewing purposes, you can see how this is a fantastic webinar on the 6G technology. Thank you. Thank you so much, everyone.
Thank you.